Hi students, today we are going to discuss the remaining problem in exercise 7.3. Next one, fourth problem. Show that determinant of b plus c a square, c plus a b square, a plus b c square equal to a plus b plus c into a minus b minus c and c minus a. We have to prove this one, the factors. Let given the determinant equal to a, this is the determinant of a equal to b plus c a square, c plus a b square, a plus b c square. We have to prove the factors a plus b plus c into a minus b minus c into c minus a. Let is the factor of the determinant. Now I am taking a minus b. First one factor is a minus b. Put a equal to b, substitute in the determinant. Put a equal to b, substitute in the determinant. A equal to b, substitute in the determinant. B plus c, a equal to b square. Next row, c plus a, here a values is b, this say b plus c, b square. And third row, a, here a values is b plus b is 2b, 2b c square, 2b c and c square. Now comparing the two rows, first row is b plus c b square and the second row b plus c b square. Two rows are identical. The determinant values is 0. That is R1 is identical to R2. That is the determinant of A equal to 0. Determinant of A equal to 0. Therefore, A minus B is the factor of the determinant. Therefore, A minus B is a factor of determinant A. Similarly, we can prove B minus C equal to 0 is B equal to C substitute in the determinant. B minus C and C minus A. It is a cyclic symmetric form. Therefore, A minus B is the one other factor, B minus C another one factor, and C minus A is the factor of the determinant A. That is, next one B equal to C. Put the value B equal to C. Substitute in B equal to C in the determinant A equal to A. B equal to C, B value C, C plus C, 2C, A square, A square. Next one, C plus A, C plus A, B square, B value is C, C square. Next one, A plus B, B value is C, same C plus A, C square. C plus A, C square, C plus A, C square. R2 and R3 are identical. R3 identical to R2. That is the determinant of A equal to 0. Therefore, B minus C is a factor of determinant A. Next one, put the value C minus A is the factor. C equal to A. Put the value C equal to A, substitute in the determinant A equal. First one, C equal to A. C value is A. This is A plus B, A square. Next one, determine C plus A. C value is A plus A is 2A, B square. And third row, A plus B, C square. C equal to A square. A plus B, A square, A plus B, A square. R1 and R3 are identical. R1 and R3 are identical, then the determinant value is 0. Therefore, C minus A is a factor of determinant A. Therefore, the factors are A minus B, B minus C, and C minus A are factor of the determinant A. Now find the degree of the product of the factor. The degree of the product of the factor is the degree of the product of the factors is factors is a minus b power 1, b minus c whole power 1, c minus a whole power 1. Adding the degree 1 plus 1 plus 1 is 3. The degree of the product of the factors is 3. The next one, the degree of the product of the leading diagonal element. Leading diagonal element is the leading diagonal element. It is the leading diagonal element is b plus c b c square. B plus c b c square. 2 1 3 3 plus 1 4. That is the degree is 4. Degree is 4. Now find the difference between the degree of the product of the factors and the degree of the product of the leading diagonal elements. 4 minus 3, m value equal to 1. Take m value is 1. Here m equal to 1, then find the other factor. The other factor is k into a plus b plus c. Therefore the other factor is the form k into a plus b plus c. The factor is k into a plus b plus c. Given the determinant b plus c is a square. Next one, c plus a b square. And third row, a plus b c square equal to, getting the factors, k into a plus b plus c into a minus b minus c into c minus a. That is the factors. Now find the value of k. Put the value a value, b value, c value. Substitute the values. So I am taking the values, put a equal to a value, put the value a value is 0. B equal to 1. B value 1. C equal to 2. So I am taking the value a value 0, b value 1 and c value 2 or minus 1, anyone. Taking any one of the value. Put a value is 0. A value is 0, b value 1 and c value is 2. Now substitute in the determinant. First one, b plus c. B plus c is b plus c, 2 plus 1, 3. 2 plus 1 is 3. A square. A value is 0 and a value is 0, a square is 0. And the second row, c plus a, c value 2, 2 plus 0 is 2. Next one, b square, b value 1, 1. And third row, a plus b, a value 0, b value 1 is 1. C square, c value 2, c square is 2 square is 4 equal to k into a plus b plus c. A plus b plus c, a value 0 plus 1 plus 2 is 3. Into a minus b is 0 minus 1 is minus 1. B minus c is 1 minus 2 minus 1. Minus 2 minus 1. Next one, c minus a. C minus a is 2 minus 0 is 2. C minus a is 2 minus 0 is 2. Now expanding the determinant in row wise. Take the element 3 into column and row are eliminated, getting the minor matrix. 1 4s are 4, 4 minus 2. 4 minus 2 is 2. 4 minus 2 is 2 equal to, next one, k into 3 into minus 1 into minus 1, minus into minus is plus. Plus 1. 1 into 2 is 2, 2 3s are 6, 6k. 6k. 3 2s are 6, 6 equal to 6k, k equal to 1. K value equal to 1. K value 1 substitute in the determinant. K value substitute in the determinant, that is K value substitute in 1. Given the determinant is a equal to k values is 1 into a plus b plus c into a minus b minus c into c minus a. That is the determinant of a. Therefore, the determinant of a equal to A plus B plus C into A minus B, B minus C into C minus A. Hence it is proved. Hence proved. Next problem. Question number 5. Solve given the determinant equal to 0. Solve means find the value of x. Solution for x. Given the determinant is, now I am taking, given the determinant is A. Is the determinant A equal to determinant of 4 minus x, 4 plus x, 4 plus x. In second row, 4 plus x, 4 minus x, 4 plus x. 4 plus x, 4 plus x, 4 minus x. This is the determinant A. Now, put the value x equal to 0. We are taking the value x equal to 0, substitute the determinant. This is the determinant of A equal to determinant of, put the value x equal to 0, substitute in this determinant. X value 0, 4. X value 0, 4, 4. First row is 4. Second row, 4. Put the value x equal to 0 is getting 4, 4, 4. And third row, put the value x equal to 0, getting 4, 4, 4. These 3 rows and 3 columns are identical. 3 rows, 3 columns are identical. Get the determinant A equal to 0. A equal to 0. X minus 0 is the factor of the determinant. 3 rows, 3 columns are identical. X minus A whole power R minus 1 is the factor of the determinant. That is, therefore, x square, 3 rows or 3 columns, 3 minus 1 is 2. X square is a factor of determinant A. Factor of determinant A. First one. Over. And the second one, we are going to put the value, now I am taking, put the value x equal to minus 12. I am taking the value x equal to minus 12, substitute in the determinant. This determinant A equal to the value x equal to minus 12, substitute in the determinant 4 minus 12. 4 minus of minus plus. 4 minus of minus is plus. 4 plus 12 is 16. Next one, 4 minus 12. 4 minus 12. 4 minus 12 is minus 8. Next one, 4 minus 12 minus 8. Now, I am taking the value x equal to minus 12. Minus 12 substitute in the determinant. I think 16 minus 8 minus 8. On the second row, 4 plus x. X value is minus 12. 4 minus 12 is minus 8. Next one, 4 minus half minus is plus. 4 plus 12, 16. Next one, minus 8. And third row, 4 plus 4 minus 12, minus 8. Next one, minus 8. 4 minus half minus plus 4 plus 12 is 16. First column, 16 minus 8 minus 8. And second column, minus 8, 16 minus 8. And third column, minus 8, minus 8, 16. Now, adding the 3 columns. Adding the 3 columns. 16 plus 16 minus 16 getting 0. And the value is 0. Now I am right. C1 gives C1 plus C2 plus C3. C1 plus C2 plus C3. 16 minus 16, then the value is 0. 16 minus 16 value is 0. 16 minus 16 value is 0. And the second column as it minus 8, 16, minus 8. In third column as it minus 8, minus 8, 16. Any row, any column are 0, when the determinant value is 0. If the determinant value is 0. Determinant A equal to 0, x equal to minus 12. Minus 12 this side, x plus 12. Therefore, x plus 12 is a factor of determinant A. X plus 12 is a factor of determinant A. Therefore, the factors are, first one is x square is the one other factor. X square and x plus 12. Next one, the degree of the factors. First one, the degree of the factors. The degree of the product of the factor. The degree of the product of the factor is 2, 1. 2 plus 1 is 3. The degree of the product of the factor is 3. The next one, the degree of the product of the leading diagonal. The degree of the product of the leading diagonal is x into x into x is x cube. The degree of the leading diagonal. The degree of the leading diagonal equal to x into x into x is x cube. That is x cube is the degree is 3. The degree of the product of the factors is 3. The degree of the leading diagonal element is 3. Now find the value m. M is the difference between the degree of the product of the factors and the degree of the product of the leading diagonal. M equal to 3 minus 3. 3 minus 3 is 0. 3 minus 3 equal to 0. Getting m equal to 0, therefore the other factor is constant value k. Therefore the other factor is k. The factor is k. Now given the determinant is 4 plus x, 4 minus x, 4 plus x, 4 plus x. Next row 4 plus x, 4 minus x, 4 plus x. The third row 4 plus x, 4 plus x, 4 minus x equal to k into one of the factor is x square into x plus 12. X square into x plus 12. That is the factors. Now find the value of k. Now find the value of k. Put the value k. Put the value x. Put the value x equal to any one of the value. Taking any one of the value. Now I am taking x equal to 1. Taking x value is 1. Put the value x equal to 1, substitute in the determinant. That is the determinant 4 minus 1. 4 minus 1 is 3. 4 minus 1, 3. 4 plus 1, 5. 4 plus 1, 5. Next one, 4 plus 1 is 5. And second row, 4 plus 1, 5. 4 minus 1, 3. 4 plus 1, 5. 4 plus 1, 5. 4 plus 1, 5. Next one, 4 minus 1 is 3. This is equal to the value x value is 1. K into 1 square is 1. 12 plus 1 is 13. 13 into k, 13k. 13k. Now expanding the determinant. Now expanding the determinant row wise. First one, take the element 3. 3 into 3 3s are 9. 9 minus 25. 9 minus 25. 9 minus 25 minus 5 into taking element 5. Column and row are eliminated, getting minor matrix 5 5 5 3. 5 3s are 15 minus 5 5 25. Next one, plus 5 into taking the element 5. Column and row are eliminating, getting the minor matrix 5 3 5 5 5 5 25. 25 minus 5 3s are 15 equal to 13k. Equal to 13k. Next one, 3 into 9 minus 25. 9 minus 25 is minus 16. Minus 16. 16 into 3 minus 48. Minus 48. Next one, 15 minus 25 minus 10. Minus 10 into 5. Minus 10 into minus 5. Minus into minus plus 10 into 5 are 50. Plus 50. Next one, 25 minus 15. 25 minus 15 plus 10. 10 into 5, 50. Plus 50. Equal to 13k. 50 plus 50, 100. 100 minus 48. 100 minus 48 is 100 minus 40. Or 50 minus 48, 2. 50 plus 2, 52. 52 equal to 13k. 13k. Now find the value of k. 13k equal to 52. K equal to 52 by 13. 4 times. k equal to 4. Here k value substitute in the determinant. So the determinant is 4 minus x, 4 plus x, 4 plus x. And second row 4 plus x, 4 minus x, 4 plus x. Third row 4 plus x, 4 plus x, 4 minus x equal to k into x square into x plus 12. Already find the value k equal to 4. K value 4 substitute in the determinant. That is the determinant equal to the determinant is a. That is determinant a equal to 4 into x square into x plus 12. Here k value for 4 into x square into x plus 12. Already given the question, determinant equal to 0. Determinant equal to 0 to solve the value of x. Determinant a value equal to 0. That is the determinant a value is 0. That is 4 into x square into x plus 12 equal to 0. 4 into x square into x plus 12 equal to 0. For that side value is 0. The one of the factors x square equal to 0 and x plus 12 equal to 0. X square equal to 0 means x value is 0 multiply of 2 times. This will be 2 times x equal to 0 comma 0 and x plus 12 equal to 0 is x equal to minus 12. X equal to minus 12. Therefore the solution x equal to 0 comma 0 and x equal to minus 12. This x square into x is x cube. X cube is the cubic polynomial, cubic degree equation. Degree is 3, getting 3 solution. Therefore the solution is x value x equal to 0, 0 and minus 12. The next one, sixth problem. Show that determinant 1 x square, 1 y square, 1 z square equal to x minus y minus z and z minus x. Show that the result, take LHS equal to RHS. RHS side is the factor of the determinants. Given the determinant, let A equal to the determinant 1 x square, 1 y square, 1 z square. This RHS side is x minus y minus z minus x is the factor of the determinant. Now I am taking x minus y is the one of the factor. Put x minus y equal to 0, x equal to y. Put the value x equal to y, substitute in the determinant A. This is the determinant of A equal to x equal to y, substitute in the determinant 1 x value y, 1 y square. And the second column 1 y square, 1 z square. 1 y square, 1 y square, 1 z square. Two columns are identical. C1 identical to C2. That is the determinant A equal to 0. Determinant A equal to 0. Therefore, x minus y is a factor of determinant A. X minus y is a factor of the determinant A. Similarly, we can prove y minus z minus x is a factor of the determinant. Similarly, we can prove y minus z and z minus x is a factor of determinant A. Y minus z minus x is a, given the determinant is a cyclic symmetric form. Similarly, we can prove y minus z minus x is a factor of the determinants. Therefore, the factors are x minus y minus z, and z minus x. The next one, the degree of the factors. The degree of the factors the degree of the product of the factors, factors is 3. 1 plus 1 plus 1 is 3. Next one, the degree of the product of the leading diagonal, the degree of the product of the leading diagonal, product of the leading diagonal is leading diagonal 1y square. Sorry, 1y z square. 1y z square 2 1 3 is 3. It is 3. Next one, find the difference between. Next to find m. M is the difference between the product of the factor, the degree of the product of the factors and the degree of the product of the leading diagonal. 3 minus 3. 3 minus 3, m equal to 0. M value equal to 0. Get the m value 0, the other factor is the constant value. Therefore, the other factor is constant value k. Other factor is k. The other factor is k. Given the determinant is 1 x square, 1 y square, 1 z square equal to k into the factors k into x minus y minus z, and z minus x. Now find the value of k. Here k value find out. Put the value x, y, z. Now I am taking any one of the value. Put the value x equal to 0. I am taking x value 0, y value 1, and z equal to minus 1. Z value minus 1. X value 0, y value 1, and z value is minus 1. Substitute in the determinant. 1, x value 0, y value 1, this 0. Next one, 1, y value 1 square is 1. Next one, 1, z value 1, and z square is 1. Now I am taking the value x value 0, y value 1, z equal to minus 1. Two columns are identical, that is the value is 0. Now I am taking value is not defined. The taking value is not defined. So z is taking the value is 2. Taking the value is 2. Now substitute in the determinant. Put the value x equal to 0, y equal to 1, and z equal to, substitute in the determinant 1, 0, 0, and y value 1, 1, 1. Z value substitute in the determinant 1, 2, 4. 2 square is 4. Equal k into x minus y. X minus y 0 minus 1 is minus 1. X minus y. Next y minus z. Y minus z is 1 minus 2 is minus 1. Z minus x. 2 minus 0 is 2. 2 minus 0 is 2. Now expanding column wise. Expanding the determinant by column wise. First one, take the element 1 into row, column are eliminate. Column and row are eliminate, getting the minor matrix 1, 2, 1, 4. 1 4s are 4. Minus 1 2s are 2. Equal to minus 1 into minus 1, minus into minus is plus. Plus 1, 1 into 2, 2k. 4 minus 2 is 2, 2 into 1, 2. That is 2k equal to 2, k value equal to 1. K value equal to 1. K value 1, substitute in the determinant. K equal to 1, substitute in the determinant. That is the determinant is A. That is the determinant. Therefore, the determinant A equal to k value 1 into x minus y, y minus z, and z minus x. Hence prove. Next example problem. Example 7.25. Prove that determinant A equal to q plus r whole square, p square, q square, r plus p whole square, q square, r square, p plus q whole square equal to 2 times of p q r into p plus q plus r whole cube. You have to prove this value. 2 times of p q r into p plus q plus r whole cube. Given the determinant of A is given already. Determinant of A is q plus r whole square, p square, and in q square second row r plus p whole square q square. And third row r square p plus q whole square. Now put the value p equal to 0. Put the value p equal to 0. Already PQR is a factor of the determinant. Put the value p minus 0 is a factor. P equal to 0, substitute in the determinant. That is a determinant A equal to p equal to 0, substitute this one. Q plus r whole square. So 1 q plus r whole square. P square, p value is 0. It is 0, 0. Next one, q square. R plus p whole square. P value 0 is r square, q square. R square, q square. And the third row, r square. P value is 0, is q square. The determinant A is q plus r whole square, q square, r square, 0, r square, 0, q square. Now I am taking r square, q square common from C2 and C3. Taking r square and q square common from C2 and C3, getting 0, 1, 1, 0, 1, 1. Comparing the two columns C2 and C3 are identical. C2 and C3 are identical. Any two row and any two columns are identical, getting the determinant values is 0. That is a determinant of A equal to 0. Determinant of A is 0. This p minus 0 is a factor of the determinant. P minus 0 is a factor of the determinant. Therefore, p minus 0 is p. Therefore, p is a factor of determinant A. P is a factor of determinant A. Similarly, we can prove q equal to 0 and r equal to 0. P equal to 0, substitute in the determinant, and r equal to substitute in the determinant. Also, determinant A equal to 0. So, the determinant A is in the cyclic symmetric form. Therefore, the determinant A is the cyclic symmetric form. Cyclic symmetric in PQR. Therefore, the factors are PQR. The next one, the degree of the factors. The degree of the factors PQR is 3. The next one, other factors. Next one, find other factors. Put the value P plus Q plus R equal to 0. Put the value P plus Q plus R equal to 0. P plus Q plus R equal to 0. Given the determinant is Q plus R, R plus P, P plus Q. Now find P plus Q, R plus P and Q plus R. Now P plus Q plus R equal to 0. Now I am taking P plus Q is P plus Q equal to minus R. Next one, Q plus R equal to minus P. Next one, R plus P equal to minus Q. Taking the value P plus Q plus R equal to 0, P plus Q equal to minus R, Q plus R equal to minus P, R plus P equal to minus Q. Substitute in the determinant. Substitute in the determinant A. Determinant A equal to R Q plus R whole square, P square. Next one, Q square, R plus P whole square, Q square. Third row, R square, P plus Q whole square. Now substitute the value P plus Q, Q plus R and R plus P. Q plus R is minus P. Q plus R is minus P whole square is P square. Next one, Q square. R plus P is minus Q whole square is plus P square. Q square. The next one, and third row, R square, P plus Q is minus R whole square is plus R square. P square, Q square, R square, P square, Q square, R square, P square, Q square, R square. Three columns are identical. The determinant values is 0. The determinant values is 0. That is the determinant A equal to 0. A values is 0. Therefore, the factor P plus Q plus R whole square is the factor of the determinant. Therefore, P plus Q plus R whole square. That is, whole square means number of rows and number of columns are identical, R minus 1. 3 rows are identical, 3 minus 1 is 2. P plus Q plus R whole square is the factor of determinant A. Already one of the factors P, Q, R will be factors, and another one factor is P plus Q plus R whole square. Next one, the degree of the factors. The degree of the factors is PQR. PQR is 3. 3 plus 2. The degree of the product of the factor is 5. The degree of the product of the factor is 5. The next one, the degree of the product of the leading diagonal elements. Leading diagonal elements is Q plus R whole square, R plus P whole square, P plus Q whole square. Is 2 plus 2 plus 2, 6. The degree of the leading diagonal is 6. Next one, find M, where M is the difference between the degree of the product of the factors and the degree of the product of the leading diagonal elements. 6 minus 5. 6 minus 5. 6 minus 5 is 1. This M value equal to 1. M equal to 1, getting the value M equal to 1, then find the required factor. Therefore, the other factor is K into A plus B plus C. Therefore, the other factor is K into A plus B plus C. Here the element is P, Q, R. Taking the element is P plus Q plus R. Therefore, the other factor is K into P plus Q plus R. Given the determinant Q plus R whole square, P square. Next one, Q square, R plus P whole square, Q square, and R square, P plus Q whole square equal to, getting the factors are K into P plus Q plus R into PQR into P plus Q plus R whole square. K into P plus Q plus R into PQR into P plus Q plus R whole square. P plus Q plus R into P plus Q plus R whole square is P plus Q plus R whole cube. That is equal K into PQR into P plus Q plus R whole cube. Next, now find the value of K. Put the value P, Q and R. The value P value 1. Now I am taking P value 1, Q value 1 and R value is 1. P value 1, Q value 1 and R value 1. Substitute in the determinants. Now substitute the value P value 1, Q value 1 and R value 1. 1 plus 1 is 2. 2 square is 4. 2 square is 4. P square 1, 1. Next one, Q square 1. Next one, 1 plus 1, 2 square is 4. Q value 1, 1 square is 1. Next 1, R value 1, R square is 1, 1. Next 4 equal to K into P, Q, R. P value 1, Q value 1 and R value 1 is K into 1 plus 1 plus 1. 3 power 3 is 3 cube. 3 cube is 27. Next, expanding the determinant. 4 into 4 4s are 16. 16 minus 1. 4 4s are 16. 16 minus 1 is 15. Minus 1 into, eliminating column and row. 1 1 1 4. 1 4s are 4. 4 minus 1. 4 minus 1 is 3. Plus 1 into, eliminating column and row. 1 4 1 1. 1 1s are 1. 1 minus 4. 1 minus 4 is minus 3 equal to 27K. Next one, 15 into 4 is 60. Minus 3. 1 into 3, 3 minus 3. Next one, minus 3 equal to 27k. 60 minus 6. 60 minus 6 is 54. 54 equal to 27k. That is k value k equal to 54 by 27. 27 how many times? 2 times. 2 27s are 54. That is k equal to 2. K value 2. K equal to 2, substitute in the determinant. Already taken the determinant is A. Therefore the determinant A equal to K values is 2. 2 times of PQR into P plus Q plus R for Q. Hence it is 4. Hence 4.